You have already studied univariate polynomials, that is polynomials in one variable, and their degrees in your previous grades. You might recall that, if p of x is a polynomial in variable x, the highest power of x in p of x is called the degree of the polynomial p of x. For example, 4 times x plus 2 is a polynomial in the variable x of degree 1, which can be called a linear polynomial. X squared minus 5 times x plus 4 is a polynomial in the variable x of degree 2, which can be called a quadratic polynomial. Likewise, we can have higher degree polynomials of the order 3 that is cubic, order 4 that is biquadratic, order 5 that is quintic, order 6 that is hexic, and so on. But the degree of a polynomial cannot be in fractions or negative. Thus, expressions like square root x minus 2, 1 by x plus 1, 1 by x squared plus 3 times x plus 2, are not polynomials. In general, we can understand a polynomial of x with degree n to be of the form a times x to the power n plus b times x to the power n minus 1 plus c times x to the power n minus 2 plus so on, where a is non-zero and a, b, c and so on are real numbers. If p of x is a polynomial in x, and if k is any real number, then the value obtained by replacing x by k in p of x is called the value of p of x at x equal to k, and is denoted by p of k. For example, for p of x is equal to 2 times x plus 1, p of 3 will be 2 times 3 plus 1 is equal to 7. Similarly, for p of x equals x squared minus 2 times x plus 1, p of minus 1 will be minus 1 the whole squared minus 2 times minus 1 plus 1 equals 1 plus 2 plus 1 equals 4. A real number k is said to be a zero of a polynomial p of x, if p of k, that is value of the polynomial at x equal to k, is 0. Consider for instance p of x is equal to x squared minus 3x plus 2. For k equals 1, p of 1 is equal to 1 squared minus 3 times 1 plus 2 equals 1 minus 3 plus 2, that is p of 1 equals 0. Similarly, for k equals 2, p of 2 is equal to 2 squared minus 3 times 2 plus 2 equals 4 minus 6 plus 2, that is p of 2 equals 0. So, in this case, k equal to 1 and 2 are zeros of the polynomial p of x as p of k equals 0 for these values of k's. In other words, 0 of a polynomial also gives factor of the polynomial. Therefore, for a linear polynomial p of x equals a times x plus b, for finding the zeros, we put p of k equal to 0 and arrive at the value of k as minus of b by a, that is the negative ratio of constant term of p of x to the coefficient of x in p of x. Thus, the zero of a linear polynomial is related to its coefficients. Does this also happen in the case of higher degree polynomials? Do the zeros of a quadratic polynomial also have some relation to its coefficients? This chapter will answer such questions. We will also study polynomial algorithmic division. Please pause the video, rewind and play again to absorb what has been covered in the topic. Let us proceed now.